Could you cook a steak by dropping it from space? The question sounds ridiculous at first, like something you'd overhear in a late-night diner between two sleep-deprived physics majors. But it's worth taking seriously because hidden in that absurd idea are some fascinating lessons about heat, speed, atmosphere, and why you don't see Gordon Ramsay suiting up with a rocket. Let's start with the premise. You've got a raw steak. Let's assume it's a nice ribeye, marbled and thick, maybe 300 grams. You also have access to low Earth orbit. Now the question is, if you drop the steak from space, will it be cooked by the time it reaches the ground? The obvious problem is that the steak doesn't just fall, it's in orbit, moving at around 28,000 kilometers per hour. Objects in orbit aren't hanging motionless above the Earth, they're constantly falling sideways. To actually drop the steak straight down, you'd have to slow it way down first, essentially canceling its orbital velocity. Otherwise, it's just going to circle the Earth as a confused astronaut snack. But let's assume you've somehow managed to give it just the right push so that it begins re-entering the atmosphere. Now, this is where the real action begins. As the steak slams into the atmosphere, the air in front of it compresses violently, heating up to thousands of degrees. This is the same reason spacecraft get wrapped in protective heat shields. So you might think, perfect, free cooking. Except it doesn't quite work that way. The heat of re-entry mostly stays in the thin boundary layer of gas around the object rather than being efficiently conducted into it. That's why space shuttles use tiles designed to endure surface heating rather than thick slabs of metal. If you touched a shuttle tile right after re-entry, it could be glowing red on the surface while still cool enough to hold on the other side. Your steak will behave more like a fragile piece of meat than a heat tile, but the principle is similar. The surface chars long before the inside feels much. At this point, the steak is screaming downwards at hypersonic speed, the outside blackening like the worst barbecue disaster in human history. The intense friction and shockwaves will tear at it, likely stripping away parts of the meat altogether. It might not even stay in one piece. Imagine crispy fragments of steak sprinkling across the upper atmosphere like some cruel parody of rain. If you're lucky, a chunk large enough makes it through. But let's imagine, against all odds, the steak holds together. Would it be cooked inside? Probably not. The outer layer would be incinerated in seconds, turning into carbonized crust, while the center remains raw, maybe even cold, depending on how fast the heat penetrates. The thermal conductivity of meat is pretty low. Even if the outside reaches thousands of degrees, the inside stays safe for far longer. Safe meaning uncooked, not edible. You'd end up with something like a meteorite steak, burnt on the surface, raw in the middle, and infused with a smoky aroma of atmospheric nitrogen oxides. 5 Michelin stars, this is not. But let's not give up yet. Suppose you engineer the drop carefully. Instead of letting the steak free fall at hypersonic speeds, you attach it to a small capsule with a controlled heat shield and parachutes. This way, you can slow its descent and give it more time to heat through evenly. But now we've cheated. The steak isn't cooking from the re-entry heat anymore, it's just sitting in a hot, insulated capsule. You might as well have used an oven. Another angle, what if the steak simply floated in orbit, exposed to the sun? Sunlight in space is strong, about 1,360 watts per square meter. With no atmosphere to scatter it, the steak would absorb a lot of energy. Slowly, it would heat up, but here's the issue. Space is also very good at cooling things via radiation. The steak would eventually reach an equilibrium temperature of maybe 120 degrees Celsius at best, depending on orientation and surface properties. That's hot enough to cook it through eventually, but it would take hours, maybe days, and the result would be jerky rather than a juicy steak. Plus, half the time it's in Earth's shadow, so your orbital barbecue is constantly switching the grill off and on. Now imagine a hypothetical extreme. You drop the steak, but you coat it with a protective, ablative layer like spacecraft have. The outer coating chars and peels away while the steak inside gradually warms. This might actually work better, kind of like wrapping meat in foil before grilling. But by this point, you've designed an over-engineered orbital steak cooker that probably costs more than 1,000 actual restaurants combined. Even if, by some miracle, the steak survived and landed with a medium-rare center, you'd never want to eat it. On its way down, it would absorb toxic compounds from the burning atmosphere. Also, it would hit the ground at terminal velocity unless you slowed it with parachutes, and a steak hitting the ground at 100 miles an hour is less food and more impact crater. You'd scrape it off the ground and find gravel mixed in with the fat. Gordon Ramsay would take one look and ban you from his kitchen for life. But there's another layer of fun to this thought experiment. Objects that fall from space, meteors, do actually cook themselves in a sense. They often arrive white hot on the surface while still being cold inside. That's why meteorites can sometimes be picked up by hand just minutes after landing. Your space steak would suffer the same fate, a burnt crust, raw middle. Space may be the universe's most expensive broiler, but it's terrible at making dinner. So, could you cook a steak by dropping it from space? Technically, yes, if your definition of cooked includes burnt to a crisp on the outside and dangerously raw inside, seasoned with ozone, soot, and molten fat raining across the stratosphere. In practice, it's not just impractical, it's a crime against dinner. If you really want space-themed cooking, you'd be better off taking a sous vide machine to the International Space Station. At least then you could enjoy a properly cooked steak while floating in zero gravity, instead of watching your dinner turn into a flaming meteor shower over Nebraska. And maybe that's the real lesson. Space isn't here to be your oven, it's here to remind us that physics doesn't care about our recipes, and that the laws of thermodynamics have no sympathy for a hungry astronaut with wild ideas. The next time someone asks if you could cook a steak by dropping it from orbit, the answer is simple. Yes, but only if you like your steak served at Mach 25 with a side of crater.